not necessarily introducing new products, it's changing the value proposition of existing products. Let's take a car, for example. It's one of the hottest areas of IoT development at all today. And you look at how this technology is changing in a disruptive fashion the value proposition of a car. So 10 years ago, we all went to buy cars. You took a look at a car, you looked at the engine, and you looked at the brand, you looked at the interior, nice leather seats, and you said, okay, that's a differentiator for me. Nowadays, you look at advanced driver assistance, you look at infotainment, you look at the safety, you look at the autonomous features. If you're me, you look at parallel parking assist, because I'm terrible at it. And this is what is now driving the value and distinguishing a brand for a company. We're really on the brink of a disruption in how we define the value propositions of these products. Keep in mind, whenever you're talking about vehicles, cars, airplanes, drones, you're talking zero tolerance for failure. This is not a cell phone that, if you're not happy with the performance, you throw away and get the other cell phone. This is any failure in these systems that results in any catastrophic, goes off course, crashes, whatever, is going to potentially result in loss of life. And that's going to be one of the key engineering challenges that I can see going forward. How do you ensure that zero tolerance for failure going forward? And this is the challenge of these design engineers. So why are some companies more successful than others? If they have access to the same tools, access to the same engineering talent, what are they doing better? And what they found was the companies most likely to succeed were taking this holistic approach to simulation. So they really saw value in helping their engineers collaborate, provide them access to this workflow that gets them out of their silos. And they found that these exactly were the companies with less development time, faster development time. They had less turnarounds, less respins, and they were more likely to be successful. And as a matter of fact, they even found that almost 40% of the respondents said lack of collaboration was one of their biggest challenges they faced every day. So definitely, what's distinguishing successful companies is the ability to simulate. And the ability to simulate, again, not just on a product, not just on a component, but at the system level. You can use simulation to optimize its connectivity, optimize its ability to collect data, last longer, and you can use it to make it lower cost or lower weight, what you're optimizing for. Now, is that the end of where the Internet of Things is going to help you? Just connecting to the internet? Is that the end of the story? And absolutely it's not. So the idea of the digital twin is that you are creating a complete virtual system prototype that performs and reacts, behaves just like the physical prototype. Where can that come into place? Well, first of all, if this is an expensive device, expensive system, and you're investigating modes of failure, so you want to understand how this fails, you certainly don't want to break it. If it costs $100,000, $500,000, $1 million, you don't want to break this just to understand what a failure looks like. It's much easier to take a model, simulate it, and understand the mode of failure there. So that's the concept of the digital twin, where we're simulating the entire system. And this is what blows my mind, because not only can I predict when parts are most likely to fail, this is huge. This is huge for any industrial application, because it's very expensive to take anything out of service and fix it if it doesn't need to be fixed. Likewise, it's very expensive if a part breaks, but you actually could have predicted that it needed to be serviced a month in advance. And that's where this predictive and prescriptive maintenance is going to be made possible. need more than just the 3 PhDs collaborating. Okay, we need engineers collaborating, we need non-analysts collaborating, we need designers. Okay, we need designers collaborating. They need to be working on chassis designs. They need to be working on form factors. They need to be maybe doing some early simulation on their own and giving it over to the engineers and say, hey, I think this is going to work. Not only is it beautiful, not only is it great, not only can it be light, but I think this could be our next gen product. And then the engineers say, yeah, you know, I can make that work. I can get a package and a chip into that. We can get a cooling solution in there. This is the only way collaboration is going to happen.